Hello and welcome back to our second part of similar triangles. And this is similar triangles, and we'll put a hyphen there, and we'll call them problems. And hopefully we got everything straightened out yesterday, so you're not thinking, holy cow, I got more problems to deal with. No, this is actually word problems, real world applications. So what's the goal? I want you to be able to use similar triangles to measure distances and objects that are difficult to measure. All right, and we're going to do some real world applications. You're going to pretend to think this is cool because it makes me happy, and then you can roll your eyes at me later, all right, when you leave the class. But anyway, problems with similar triangles. So first example here, measuring Zach. So some person called Zach is so tall, we just can't measure him with a measuring tape. So Chad, who knows that his eye is, so since Chad's not here with me, I'm going to guess. I'm going to say Chad's probably, 120 centimeters from his eyes to the ground. And he positions a mirror between the two. Okay? And it's 2 meters from Zach's feet. All right? Then he walks backwards until Zach's head is visible in the center of the mirror. Chad is now, I don't know, I'll fill it in. Let's say he's 25 meters from the mirror. How tall is Zach? All right, this is the first thing I'm going to, if you ask for help with this particular lesson, this is the first thing I'm going to yell at you if I don't see it. And I like yelling just because it's fun. So draw a picture. All right, I'm already yelling at you and you don't even know what you're supposed to do. My goodness gracious, draw a picture, because these questions are impossible without a picture. There's so much writing here. We need to break it down, and we need to use a picture. Absolutely draw a picture. I'm already getting upset, so let's calm down. So anyway, back to what we said. Chad knows that his eyes are 120 centimeters. So this is Chad. Hi, Chad. There we go. So Chad knows that his eyes are 120 centimeters from the ground. He walks backwards. We got to put Zach in. So here's this tall guy. I'm Zach. My arms are really low on my body. Okay, so here's the mirror. And the mirror is 2 meters away from Zach. Chad walks backwards until he can see Zach's head in the mirror. So, actually, let's go with, it's kind of funny, but anyway, what's basically happening is line of sight. So Chad is looking in the mirror so he can see the top of the head. So you can start to see that triangles are involved here. So, kind of jumping ahead and ruining the surprise for you. But we're going to have similar triangles here. And here are the two similar triangles. All right. So, we know that Chad moved back 25 centimeters. Or 25 meters. Let's change that to centimeters. That way you don't have to erase anything. Move that to centimeters right there. Up in the question. All right. So this is 25 centimeters. We want to know how tall Zach is. So what is his height here? So we're looking at X. So a couple things have made this question challenging. We have a different set of units going on here. So we got to be careful, and I'm going to do my conversion right away. So 2 meters is 200 centimeters. All right. Okay, so let's identify our similar angles. Well, we're assuming that Zach and Chad are standing straight up and down. So here are 90 degrees. Okay, so those are 90 degrees. When you are looking at a mirror or looking at a puddle, we have what we call the laws of reflection. And that says that an angle that's striking a mirror is going to equal the angle reflecting from the mirror. So those two are equal as well. So what that allows me to do is label my triangle. So I have A, B, and C, D, and E. So I'm going to match up the corresponding lengths. So shadows and reflections are on the ground here. So I know that AB, the height of Chad, is going to equal BC. Well, that won't be equal, but it's part of the fractions, and then AC. Okay, so I've set up the Chad triangle. Now, if I go to the Zach triangle, AB matches up with DE. BC matches up with EC. And finally, AC matches up with DC. All right. Fill in my information. So AB is 120. DE is my unknown, so that's good. That's what I'm looking for. BC is 25. EC is 200. I don't know anything about AC, and I don't know anything about DC. So guess what? That fraction, shit, no good. We cut that fraction right out. So we don't have to worry about a fraction A that has nothing, no information we want, and B has nothing, no information that we need. So that being said, now we just need to solve for our value of x, and we can do the cross multiply here. So we get 120 multiplied by 200. That's equal to 25 times x. The 25 is multiplying the x, so we're going to divide by 25, and we get an answer of x equals 960 centimeters. So the last part here, therefore, Zach is 960 centimeters tall. So there you go. So what's involved here? When I'm looking at marking and doing the assessments, all right, 1, I want a diagram. 2, you match up the sides for me. 3, you do your substitution. 4, you solve with whichever method. And 5, you get a therefore statement for me, so it's not all nice and cleaned up. So those are the 5 components that are must-haves when you're drawing up solutions. All right, on to example number 2 here. So to determine how tall a statue is, a mirror is placed in the ground, and you move away until you just see the top of the statue. The following diagram represents the situation. What's the height of the statue? So number 1, this is great because the diagram is done. I identify my 2 triangles, boom, boom, and boom, boom. Right angle, law of reflection, law of reflection. So there we go. There's my similar triangles. Label the corners, A, B, and C, D, and E. And this is virtually similar to the one above. So that's step 1. Step 2, set up your ratios. So AB, AC, and BC. So I'm doing my big triangle first. It's going to be my numerators. AB matches up with DE. AC matches DC. And BC matches EC. All right, so there's phase 2 done. Phase 3, substitute in values. So AB is X, DE is 1.8, AC I know nothing about, and DC I know nothing about. BC is 4, EC is 2.4. So again, that middle fraction, we know nothing, need nothing, so she's a no good. We get rid of her. Which leaves us with 2 fractions equal to each other. And now we're just simply calculating. And now I'm going to talk about the cross-multiplying method is great, but if the x is on top, if I multiply the 1.8 up here, my x is by myself. So this is what I call a half cross-multiply. Half cross multiply. It saves me work because the goal is to get x by itself. So why would I multiply the 2.4 up when I want to get rid of the 2.4? So this is one of those cases where I'm not going to multiply the 2.4 up. I'm going to do what I call half cross multiply. And the x is by itself. So the 1.8 goes up, x is by itself. We shut her down. So calculating that out, we get x equals 3. So therefore, the statue is 3 meters tall. On to the next example. Did you know that any shadow cast by the sun at any given moment will form a similar triangle with any other shadow at that given moment? Pretty cool. This is how the Egyptians predicted the height of the pyramids. And this is how, and I'll show you the example on the how. So a 1 meter stick is placed in the ground in order to determine the height of a tree. So a quick diagram. I'm going to make a blue tree because I like blue trees. Here's my sun. The sun's blue as well, mainly because I'm too lazy to get the change the color. So the shadow of the tree is on the ground here. So here's the shadow. I'm going to put the 1 meter stick in. And lo and behold, the shadow itself for the tree is 8.7 meters. And what I'm going to do, I'm going to, I guess here, I'm just going to put it in the same picture, but that might be a little bit confusing. So at this point in time, I'm just going to leave it like this. So that's 8.7. So if I was to put the meter stick in the ground, it would cast a shadow as well, and it's 1.6 meters. And it's a meter stick, so it's 1 meter tall. So again, both objects make it 90 with the ground, and the angle of the sun is shared. So there are my two triangles. So I'd have triangle ABC and DEF. So step one is to go ahead and match them up or line them up. So AC, AB, so I'm just taking it from the tree diagram, CB. Next, I take the measurements or the sides that correspond with this from the meter stick. So I have DF, AB matches up with DE, and CB matches up with FE. Once I've done that, I plug in the known information. So AC is what I'm looking for. I want to know the height of the tree. DF is 1. AB, I don't know anything about. DE, I know nothing about. CB is 8.7. FE is 1.6. Again, that middle fraction, she's a no good. We get rid of her. And the nice thing is x divided by 1 is just x. So we just have to hit 8.7 divided by 1.6 on the calculator. And we end up with 5.4 meters approximately. So therefore, the tree is 8.4 meters tall. There we go. I have one last example I want to do. Pretty important. So I'm going to hold off, and I'll do it in the next video just so I have enough time. I need another 5 minutes. So that's about the length of the next video.